Okay, I'm going to start a very short video this morning, and I don't generally show any machining in my videos to date, and they've mostly been about the hand shaper that I've been building and I'm still working on. So but that said, I've had a set of taps and dies that I've probably been using for 40 years, and they're hexagon shaped. So I've done various projects around the shop over the years with them, but you know, they don't work good for the lathe. And I do have a set of 1-inch round taps and dies that I use on the lathe from time to time. And as you know, I have a mini lathe, Chinese mini lathe, and I also have a little small TAG micro lathe. So anyway, I have a die holder for the TAG. Actually, that's what it was originally for. It holds 1-inch dies and some other size that I don't use, some smaller dies, and got a 1/2-inch arbor basically, and it's got 4 set screws. So that's worked for me actually. I've used that. I just chucked this up in the chuck on the mini lathe. It doesn't have much travel. That's one thing that I don't like about it, and it just holds the 1-inch dies. So anyway, last week or earlier in the week, I decided to build a holder for hexagon dies. So hopefully this video is not going to get too long. So I'll just tell you what I did. I took a piece of 1 3/4-inch rod, and it's just a simple procedure actually, so not much fancy machining involved or anything like that, you know. So, but I needed something that was a large enough diameter to be able to have some meat left over on the outer edge. Now I've seen some people make these similar to this anyway, not exactly like this, but similar, and they got nothing left over here, and they usually put a set screw in there to hold the die. That seems to be commonplace. So what I did was I took a piece of 1 3/4 rod, about 3.5 inches long, or 3 inches plus the thickness of the die, the hexagon die, and all I did was drill a hole straight on through the entire piece, and I used a couple different size drill bits to accomplish that, and I ended up with the 1/2-inch drill bit at the end, just taking off a small amount, which actually enabled a piece of tool steel or silver steel to slip right in there nicely. So that makes a good fit, no problem. I left this at 1 3/4 inches, just enough to, I took off just enough to clean it up in the lathe, and then I took several inches, or I don't know what this is, maybe 1.5 inches or something at this end, and I turned it down to whatever diameter I needed to put a 1-inch hexagon on here for a 1-inch spanner. I've seen people that just took the entire diameter, which was usually smaller than this, and just make a square end, but that didn't seem very practical to me. The hexagon end seemed much better. So I did that, and then what I did here on this end is I just bored a pocket in here deep enough for the die, the hexagon die, and I got an old 1-inch socket, and I cut some pieces off of it. It was actually long enough to get 2 pieces off of it. Here's the old socket now. You can see it's been, you know, cut off. Here's one piece I cut off. That was the first piece I cut off. But that was the, you know, the business end of the socket, and it wasn't in beautiful condition. So I had enough room on the socket to cut another piece off. So I cut another piece off, and I measured the socket and made the bore about 1.5 thousandths or something smaller. So I get a good interference press fit. Then I took it over to the hydraulic press and pressed it in there, and that actually holds quite well. This, I've tested this, it works fine. I don't have a set screw in here. I don't really need one, but it might be handy. So I may do that eventually. And then I just face this off, and so anyway, I got a die holder. It works extremely well. Some people say that, you know, Hexagon dies aren't supposed to be used for cutting threads, but I don't know. You know, I've used this set for 40 years for cutting threads, so I don't quite know what they're talking about. Maybe some of the later ones are not made, they're just made for chasing threads, I don't know. But anyway, my hex dies, now I can use them on the lathe. They cut nicely, and so anyway, I just wanted to point that out. So after that, I decided to make another die holder, basically the same way, for round dies. So I cut another chunk of rod off, 1.75-inch rod, and in this case I don't need quite that big a diameter. So right now I've begun taking some of the diameter down, and I think what I'm going to end up with is about 1.5 inches, I guess. That way I have a 1/4 inch either side of the bore left to actually put a threaded set screw in. Now this one, they put 4 set screws, which seems to be quite adequate. Actually seems to work quite well. My dies, I think, only have one in, they're solid dies, number 1, and number 2 is they only have 1 indentation. So actually only one of these set screws goes into the indentation. The other 3 just hold the die in place. So anyway, that's what I'm going to do. I don't like these holes I've had some trouble with the bars bending on me, and I've actually let me see here if I can find one. I actually took some silver steel and made some bars that are a little heftier, turned down the end and hardened it a little bit. So they actually work fairly well, but I like the idea of having the Hexagon on there, so that's what I'm going to do on this one too. So what I'm going to do is continue to turn this down, which is just a laborious process. I'm running the lathe a little slower so the chips will break, because if I don't, I get these big long streamers, you know. So I'm just running the lathe a little slower, and so the chips will break. And I've got to get this down. I got to take 1/8 of an inch basically off of the that'll take 1/4 of an inch off the diameter. So that's what I'm in the process of doing. I've taken it down a little bit here, but I got quite a ways to go. I didn't have a chuck large enough to hold this. I have a 4-inch chuck on this lathe, but when it's cranked all the way out, it won't really hold 1.75-inch piece of material. So I had to put the other jaws on here, and I didn't want to have to bother with the steady rest, so for this short a piece. So I managed to, bore the end for a dead center, and then I can just flop this back and forth. Once I get this turned down to 1.5 inches, then I can put the other jaws back on the chuck and turn this other end down for the hexagon. So that's what I'm in the process of doing. And so I'm going to share some of the machining process and this project. Hopefully it only takes 1 or 2 parts, I don't know. So we'll see how it goes. So here we go. We're going to fire up the lathe and start moving this down. See where I'm at here. A little cutting oil on here. And like I say, I'm running this pretty slow so the chips will break. But I will fast forward through it so it doesn't make too long a video. The diameter is pretty good size too, so I don't want it to chatter either, and it has a tendency to do that. So you can hear it starting to chatter there. So once the diameter gets smaller, I won't have that problem, but the chips are breaking in little short pieces now. Usually not more than 1 inch long, so we'll make one pass here, and then I'll fast forward through the rest until we get down to 1.5 inches. Then what we're going to do is we're going to flop this over and center drill the other end. And this will fit in. I'll change the jaws on the chuck, because once this is down to 1.5 inches, I can actually chuck it up. I guess it would benefit me to have a 4-jaw 4-inch chuck, but I don't have one. I have several 4-jaw chucks that are 3-inch or whatever the size is for this mini lathe, but I don't want to fool with those. I'd rather have a 4-inch actually. This is just a piece of 10/18 steel. I didn't have any pieces around the shop in order to build this thing initially. So I went out and bought a 12-inch piece, 1 3/4 10/18. So this will make. I'm using half of it at this point to make the 2 die holders. So what's that? Maybe about a $8 expense. So that's the extent of the expense, I think. That's it. The rest of the stuff I just have laying around the shop. So, and I can use the same piece of silver steel for the mandrel or arbor in this one that I used for the other one. I would like to have a 1-inch spanner. I have some 1-inch special spanners, but they're not very heavy. So, and I really don't want to use a crescent wrench on it. This takes about 3 trips around the dial. A little bit more than that actually. 3.5 trips around the dial to get this down. Needs a little oil on it. I think rather than fast forward through this, I think what I'll do is I'll shut the camera off right now, and then I'll bring you back when I get this down to the diameter that I want. I might mention that we're probably on our last pass here. Not taking off very much. This dimension isn't that critical, but you know, it's always good to work to a dimension. So 1.5 is the dimension that we want to come up with. So I'm sure it's not going to be perfect, but should be pretty close. Maybe allow a little bit to polish. We're not going to polish now, but eventually we're going to polish it a little bit. Also, I might mention that with the tool bit I got on here, it just got a slight, very slight cant to the insert. So I was able to reach into this end and clean that up too, which I'd done prior to beginning this video. So I can't reach into the right to the center, but considering we're going to bore a 1/2 inch hole or drill a 1/2 inch hole through there, that part really doesn't matter. We ended up with quite a few chips here in the process. I've been scooping them up little by little and dumping them in my bucket here. Since I'm taking off less material right now, even though I'm running at a slower speed, we're getting longer streamers off there. I'd much rather clean up the little chips than the long streamers. That's my preference anyway. The other end we got to take down quite a bit more, but for a shorter distance. So let's see where we're at. I'm just using the calipers to check it. It's probably not the most accurate way to do it, but well, there we are. We're a 1/2 thousandths off, something like that, so hair under for the calipers, 1/1000th off there. So we're good, you know, and the finish looks okay. Not perfect, but it's a little, this insert's a little pointy, so to speak. I have another one with a more rounded end on it that would work better, but this will polish up okay eventually. So now it's time to take this out and flip it around And in the process, I need to change the jaws back to the conventional jaws on the chuck. So I'll bring you back when that's done. Okay, that just took a few minutes. I changed the chuck jaws, and I flipped this thing around and faced off the end a little bit and bored a center hole in there so I could use the live center. So now we need to take off. Let's see. I'm gonna go get a. Here's the tape measure. So looks like on this one I left 2 inches on that portion. So this portion ended up to be about an inch and a half, something like that. Now let's see. I'm not sure that this one's exactly the same length, but it's pretty, yeah. So we need to take off about an inch and a half. Now let's see where we're at here. We can just do it this way. There's about an inch and a half right there. Always change it a little bit if we have to. That looks about right. I set the stop up there. It gives me a gauge. I can kind of keep track of this. I'm not sure what this dimension's supposed to be. I don't remember now. I don't think I made a printout at the time. I think I just remembered what it was. So just take a little bit off here and see what happens. It looks like the piece we turned is chucked up nicely and it's running nice and smooth. So we got a little lumpity-dumpity here, but that'll go away. A couple thousandths off. Let's see, this needs to roughly, what I did was I made the diameter of this part slightly smaller, I guess, huh? Slightly larger. It looks like we're about 1.1. For some reason this didn't come out perfect. I don't know why. About 1.1. We got a long way to go. See what we got here. We got 1.75 minus 1.1 equals divided by 2. Huh? So we got 325 thousandths divided by 0.040. We got 8 times around the dial here to get somewhere close. So we got a ways to go. Now let's see if we can speed this up a little bit. This is going to be a long process, so probably best I shut the camera off and bring you back when we get down somewhere close to where we need to be. And I need to figure out what that is. I have a drawing on my CAD that tells me. I guess I remembered what that was. I wrote it down somewhere, but I don't remember now. I'm going to turn the camera off right now and bring you back when we get down to where we need to be. Okay, just break in here for a minute, and I've determined that we've got to take this down to 1.25. So we're not there yet. We gotta go around the dial again to get there. After we finish this, I think it'll be time to drill the hole. So that takes a while. We gotta get through this entire length here, and I don't have any extra long drill bit, so probably to start with, the initial hole, maybe we'll drill 1/4 of an inch, and maybe we'll drill that from both ends. After that, the drill bit length might make it. The tailstock won't go that deep, so we'll have to move the tailstock several times in order to get that deep, but we just got to take our time and get a nice clean hole through there so the silver steel has a good fit in the end. So it worked out okay for the other one, so we'll see how it works. I remember it was a little bit of a tedious process. Some of these people have made videos on making these type arrangements before. Well, this is not a new idea, but I see a lot of people make them out of aluminum. I don't like that idea. I guess if whatever you use to turn the die holder with, in this case a spanner, it was aluminum. I don't think those that hex area would hold up very well. In fact, I'd even like to have a way to case harden the steel so it wouldn't get banged up. But this seems to work. I didn't have any problem. And, you know, in reality, anything bigger than 3/8 of an inch, I'm probably going to single point it anyway. I'm not going to use a die. So, anyway, I'll bring you back when we get closer. We're almost there. We don't have far to go. Maybe 20 thousandths, 30 thousandths to go. Okay, we're getting down to the final cut here, I think. See where we're at after this cut, but I think we're getting close. This diameter is a little larger than it needs to be. That way, when we cut the hexagon on there, we still end up with round corners. Of course, we can put it back in the lathe and clean that up a little bit, but that should be getting close. See where we're at here. We need 125, right? So let's see where we're at. Well, I'm going to call that good. We're at 1.251. 1.25, and there's a 5/10 over right there, or less right there. So, okay, so that takes care of that. So now we've got this part turned to a little smaller diameter than this, but for the round dies, and we've got this part turned down to eventually put a hexagon in there. One other thing we got to do is we got to put some relief in here. The way I did that was to I made a arbor, just a piece of 1/2 inch 10/18, but it fits in the hole just fine with a nut on it, and that just goes in there. I was able to take this end of it. Did I do it that way, or I must have done it this way actually? Anyway, I was able to take this end of it and chuck it up in a 5C collet, okay, and put that collet in a hexagon collet block. Probably not the perfect way to do it, but it seemed to work pretty well. So that's why. And then when we mill these flats on here, it's good. It's nice to have this relief in here, so we're not going right up against this part here. So that makes this cutting these slats really easy. So anyway, so we need to do that at this point, probably before we break it down a little bit so we can drill the hole. Let's take this off here and find something to do that with. Theoretically, we got to go in there about 1/16 of an inch or something. So we're going to go a little bit further than that. Just kind of eyeball this. So what we need to do, we need to go in there about maybe about, I think we should go in there about 80 thousandths. Let me see what we did here, if I can even measure it. We had 125 there. See, turn this thing on, might help. We got let's say 925 there. .125, so can't think. Let's say 925. So 1.125 minus 0.925 equals, divided by 2 equals, so we went on this one, we went in there 100 thousandths. Well, you know, we could do that again. That's fine. I don't see what's wrong with that. Round number. Let's get the lathe running kind of slow. Let's touch off. Let's set this at 0. That looks good enough. Got a groove anyway. It looks like here. Yeah, that looks good. Oh, let's see here. Oh, this damn thing. Did I not tighten it? You know, I've done that before. I think that's good. Looks good. Well, let's see here. I think we'll call that a wrap for this part, because I'm sure this video is getting way too long. In fact, I may have to move some of this one into the next one. But this little jewel is a nice addition to the toolbox, believe me. So I'll call off now, and we'll come back and we'll get the hole drilled. Oh, thanks for watching.